right, good morning. Here's the test review section 3 key. I'm just going to work through all these questions. If you are in one of the other geometry teachers' classes, number 1 will be just a hair different than my students, but other than that, everything should be about the same. So here we go. 1 and 9. 1 and 9 are right here. 1 and 9. If you notice, the transversal is S. They both lay on S. And they're both in the same location, top left corner. That makes those corresponding angles. 2 and 3. I look at 2 and 3. They are right next door to each other. That makes them a linear pair. So if I follow down here, they are on a line. Fantastic. If I look at 8 and 12. All right, let's see. 8 and 12. 8's way over here. It's off line M and line T, and 12 is off line S and N, both of which do not even share a line. No transversal included on both of those. That would be other. 6 and 12. So if you look at 6 and 12, kind of the same thing. 6 and 12, way too far away from each other. That would also be other. 1 and 2. All right, so 1 and 2 are right next to each other. That makes 1 and 2 a linear pair. 15 and 11. All right, so if I find 15, let me go back color. 15 and 11. So the transversal is N. They both lie on N. S and T. All right, so they're not on the inside of S and T. However, they're in the same location, bottom right corner. That would be corresponding again. Okay, 8 and 9. Let's see. So 8 is here, and 9 is here. Both do not fall on a line, the same line, no transversal included. Different places, that's other. All right, and then 2 and 4. If I find 2 here and 4 here, those are vertical angles. They are directly across from each other. So vertical angles, the unfortunate part is that is not listed up here. So we'll say other, and we'll just note that those are vertical. Notice we did not have any examples of alternate interior or same side interior. So an example of alternate interior would be like if I looked at parallel lines M and N. If I look at the transversal T, alternate interior angles would be on the inside of M and N, so maybe like 7 and 13. Okay, so an example I'll just write down here would be 7 and angle 13. Alternate interior. Same side interior, so same idea on the inside, but same side interior is on the same side of the transversal, so maybe like 7 and 14. Okay. All right, if we keep rolling here, number 2, match each term with its description. 2 angles whose measures add up to 90 degrees. That'd be complementary. 2 angles that share a common vertex and a common side. Adjacent, right next to each other. 2 angles whose measures add up to 180 degrees, supplementary. 2 non-adjacent angles that are formed by 2 intersecting lines. So there'll just be 2 lines intersecting. We're talking about vertical angles. And an angle whose measure is greater than 90 degrees but less than 180, obviously that's got to be obtuse. Okay, so number 3, Joseph bisects angle LMN. So remember, bisect means cuts in half. I'm going to draw a picture. LMN is just a slice of pizza. LMN. So if I cut this slice of pizza in half, there, I just bisected it. Label a point on the bisector as O. So here's O. Joseph measures an angle LMO with a protractor. The measure of LMO, so if I follow LMO, we're talking about this slice right here, is 41 degrees. So I'm going to put 41 right there. What is the measure of LMN? So if I follow LMN, they actually want to know what's the slice of the whole slice. We cut it in half, but what's the slice of both of these pieces together? Well, this one's 41. And this is the bisector. 41 would be down here as well. So we simply do 41 plus 41. That's 82. All right, number 4. The supplement of an angle is 5 greater then 5 times the measure of the angle. So I like to draw a picture. Supplement means 180. So we got half of a pizza box right here, 180 degrees. We've got 2 angles. We know the supplement of an angle is 5 greater than 5 times the measure of the angle. So here's one angle x. The other one is 5 greater, so that'd be plus 5. Then 5 times, so that'd be 5x, the measure of the angle. At this point, we got a representation of what's going on. Now we're just going to make an equation and solve. 5x plus 5, which is one part, plus the other part, x is equal to 180 degrees, and solve. Combine like terms. Subtract 5. Now we get 175 divided by 6. Right. If you do that, you will get a decimal, which is okay. No big deal. No big deal at all. Should get 29.16 repeating, or 175 over 6. So this is a fraction answer. This would be the decimal answer. I'm going to put in decimal answer. Hopefully your test won't be so cruel to you. The measure of the supplement of an angle is how many degrees? So at that point, all we got to do is plug this back into this piece right here and figure out that angle measure. So 5 times 29.16 repeating, plus 5. And go ahead and put that in your calculator. And we should get 150.83 repeating. Okay. All right. The measure of angle 1 down here, find the measure of angle 1, sorry. Remember, m just means the measure. So if I want measure of angle 1, first off, we have to figure out what x is. You got vertical angles, so we simply set those equal to each other. You know, my x is on one side, subtract x. Divide by 5. X is equal to 11. Careful, that's not the answer. If I plug 11 back into either side, we should get 66 both angles. But they want the measure of angle 1. Well, note on a line there are 180 degrees, so we'll take 180, subtract 66. Do some old school subtraction here. And we should get 114 degrees for angle 1. It'd be the same as angle 2. Alright, you can double check your math. 114 plus 66 would equal 180, so that makes sense. Alright, number 6. LMN and PML are linear pairs. LMN and PM are vertical angles. We have LMN, which is 7x minus 3, and PML, which is right here. And those are linear pairs. We know a linear pair is on a line. It's 180 degrees. So I'm going to draw a picture just so that we can see how this looks. So LMN, notice they share M and L. So M would be on my line here, and L would be what they share. So we have LMN, and we have PML. If I put what I have here, LMN is 7x minus 3. PML is 13x plus 3. We have on a straight line. We can go ahead and solve for x easily because we know that part plus this part is equal to the whole, which in this case is 180 degrees. I'm going to do that. Negative 3 minus 3 is 0, so those cancel. Divide by 20. Alright, so x is equal to 9. So as far as this goes, x is equal to 9, that's part A. Next, they want you to find the measure of LMN, no big deal. Plug in 9 in for right here. So 7 times 9 minus 3. That's 63 minus 3, which is 60 degrees. So this angle up here is 60 degrees. 60 degrees. Okay. If I keep reading, it says, and measure of PMR is 5y plus 4. Now note, if I go back here, they said that LMN and PMR are vertical angles. So noting PM, we have PMR right here. They share M, so that means I'm just going to extend this line out this way, and here's R. And PMR is 5y plus 4. So looking at this, how would I set this up? Well, you've got vertical angles, they say in the problem. So this angle is a vertical angle with this angle. Good news is, we just figured out what this angle is at 60 degrees, which means over here would also be 60. So in any case, all y'all really need to do is do 5y plus 4 equal to 60 degrees and solve. Subtract 4 and then divide by 5. Okay. So y equals 56 divided by 5 is a great answer. All right, that's very good. You leave it as a fraction. If you make that a decimal, you get 11.2. So both are great answers. They also, oops. Sorry. LMN should be 60 degrees. Okay, so we just figured out y. That's down here. It's 11.2. PML. Okay, so they want to know what is the measure of angle PML. PML. What's the measure of this angle right here? Oh, no big deal. We can plug in our 9 in for x and get that answer out. So we get 13 times 9 plus 3. 13 times 9, 117. Plus 3 is 120. So this angle over here is 120 degrees. Coming over here, I'm going to write that in right here. Now note, if you were like, this is on a line, 180 degrees. Subtract 60, I get 120 the same way, for sure. That's 100% correct. However, it's more accurate just to plug it into the equation separately to make sure that you did your math correctly. If you had gotten this one wrong, then you for sure would have gotten this wrong. You know, so anyway, it's just good practice to plug back in. Make sure you did your math right. All right, rolling on. Number 7, given angle 3 and 5 are same side interior angles. So here's 3, here's 5. Same side interior angles. Identify the transversal in the figure to the right. So the transversal is the line in which they both lie on. If I look at this, 3 and 5 both lie on line R. Okay, I know it looks crazy. Your railroad tracks would be these two lines here. So in any case, but same side interior, we're on R, line R. All right, number 8. Determine which lines must be parallel. Okay, if they say if x is 14, I would simply plug 14 in for every x and see what each one of these angles are, and from there we can compare. So don't worry about that. That's just there. That's accidentally there. Okay, so if I go 3 times 14 plus 36, we're going to figure that math out. 2 times 14 plus 25, and 10 times 14 minus 13. We're going to figure out all those different numbers. We would get 78 up here. You would get 53 here. And then up here, you would get 127. All right, so obviously all 3 different numbers. So what makes 2 lines parallel? Well, you have to have all those properties of parallel lines, right? So in my class, we talked about this is a pizza, and these are our parallel lines, then it should be the same pizza all the way down if I slide it down this transversal. So this is 78, down here should be 78 all across the board. So if I took 78 and put it right here, okay. Question is 78 and 53, that would be half my pizza. Is 78 plus 53 180 degrees? Well, the correct answer to that is no. 78 plus 53 are not 180 degrees. So thus R and S, there's no way those would be parallel. They're not, they don't add a 180. So R and S, no go. All right, well, what about S and T? Okay, so if 53 is the bottom left corner angle here. If I slide it down here, 53. Question is, what about 127 and 53? Well, do those add to 180? Well, absolutely. 127 plus 53 do add to 180. So thus, these two numbers make sense, 127, 53, which means S and T would have to be parallel. Okay, what about R and T? So if I skip the middle one, let's just look at these numbers. 78 was in the top left corner, but 127 is in the top left corner. They should have to be the same angle measure, and they're not. In order for them to be parallel, they'd have to be the exact same measure. They're not. So no way, Jose. Rolling on. Alright, then we got lots of solving on this side and then some proofs. So number 9, solve for the values of x and y given m is parallel to n. Okay, measure of angle 3, 7x minus 5. So we know this angle right here is 7x minus 5. We know the measure of angle 9. Let's see. M and N are parallel. So hold on, let me go like this. Make sure I know that those are parallel. So we've got that one. 9 is an alternate interior angle of 3, which means they would be the same angle, congruent. So that's also 6x. Let's see, 6x plus 1. And then they also give measure of angle 2. Measure of angle 2 is not the same as 3 and 9. And that one is 3y plus 53. Alright, so we're going to do this. They want you to find x and y. Alright, so we know we've got alternate interior angles right in here. And those are congruent when you're given parallel lines. So I'm simply going to set 7x minus 5 equals 6x plus 1 and solve. X is equal to 6. Done with that. Now, if I knew that, and if I look at measure of angle 2, it's got a y in that equation. But good news is they have 2 and 3 right next to each other. That's 180 degrees total. Sorry, 180 degrees total. So, what I'm going to do, I'm going to plug 6 back into this expression. Let's figure that out. 7 times 6 minus 5 is 42 minus 5 is 37. Alright, so I know this angle right here is 37 degrees. You can do this a couple different ways, but essentially we're taking one part plus the other part equal to 180. So I'm taking 3y plus 53 plus 37, the other part, equal to 180 degrees. And then I'm solving. Some of you guys were probably like, I'm going to take 180, subtract 37 from 180, and then set that equal to 3y plus 53. That's all good. Totally fine. We have 3y plus 90 equal to 180. Subtract 90. 3y is equal to 90 divided by 3. Y is equal to 30. Sorry, that looks bad. Alright, and we're done. Easy peasy. Alrighty, here we go. Number 10. Alrighty, so number 10, if P is parallel to Q, I'm going to mark that. Measure of angle 1 is 2x plus 10. So measure of angle 1 is 2x plus 10. 11 is 3x minus 5. So I'm going to go a different color there. 3x minus 5. Looking at 11. I'm looking at 1. Find the measure of angle 2, 4, 10, and 12. 2, 4, 10, and 12. Note, we're not even dealing with line M. That's really there to mess with you. Doesn't really matter. So good news is if we've got parallel lines, then again, this whole pizza, it's the same pizza as down here. Same pizza. So if I look, I'm given the top left corner slice and the bottom left corner slice. They're not the same slices, so we're not going to set them equal to each other. If I moved angle 1 up to where angle 3 is, I'm sorry, angle 11 up to where 3 is, they'd be half a pizza. So we would add them together and set them equal to 180. So that's what I'm going to do. 2x plus 10 is one part, plus 3x minus 5, the other part, equal to 180 degrees. Combine like terms. 10 minus 5 is positive 5. Subtract 5. Divide by 5. Alright. I'm going to do some old school division, and you should get x to be 6. Nope, I lied. Just kidding. X is 35. Okay. Which is helpful, it's just not the full out answer yet, right? So if I need to find, essentially you really just need to find 2 angles, and you'll have all the rest of the slices of pizza. So if I plug 35 into whichever expression, we'll go from there, right? So 2 times 35 plus 10. This is the measure, that's angle 1. All right, 2 times 35 is 70, plus 10 is 80. Okay, so I know the measure of angle 1 is 80 degrees. Now that is not to scale. Never go according to scale. Because this is, obviously this looks greater than 90 degrees. Sorry, it looks greater than 90 degrees, and this is a number less than 90 degrees. But no biggie, right? So angle 1 would be 80, 4 would be 80. If I bring those down, that means 9 would be 80 and 12 would be 80, right? So all those 4 would be 80. Now, if we did our math right, the other angle should just be 100 because they should add to 180. So let's just double check, make sure we got that right. So 3 times 35 minus 5, just inputting my x in. 3 times 35 would be 105. Subtract 5 is 100. So yeah, we definitely did that right. And so any of the other angles would be 100, so all the little ones 100. 100. Obviously we can't, it's just hard to see anything at this point. But if I looked at measure of angle 2, okay, so 2 would be that acute angle, which is actually 100, okay, which then would also be angle 10. All right, so 2 is up here, it's 100, it would be the same as this slice of pizza, 100, okay, and then 4 and 12 would be these big slices of pizza, which are like the same as that 80. All those are 80. Okay. Again, just don't go according to diagram. It's kind of crazy. All right, 11. The values of x, y, and z are in the figure. Okay. So we're given that all these lines are parallel. Helpful, for sure. So if I look at this first top right here, these are same side interior angles. They are supplementary, which means they added 180. So I'm going to combine 12x minus 4 plus 2x minus 12 equal to 180 degrees and start there to solve for x. Looks like I get 14x minus 16 equal to 180. Add your 16 over and divide by 14. So x equals 14. Cool. If I keep rolling to get y, well, if I look at y's, those are alternate interior angles, which are congruent, same angle. So for those, we're going to set those equal to each other and solve. All right, so we've got 2y plus 30 equal to 4y plus 5. All right, I'm going to get all my y's on one side. All right, subtract 5. Divide by 2. All right, 25 over 2 is a great answer. If you make it a decimal, that's just 12.5, which is great. So we got y, it's 12.5. Question is, how do we get z? All right, well, if you notice, 2y plus 30 and 3z squared plus, note my classes, we had to change that to 98 as on a straight line, 180 degrees. So what I would do is just plug 12.5 back into this equation here, this expression I mean, and get that angle. So I'll do that right here. 2 times 12.5 plus 30. That would be 25 plus 30, which is 55. Well, I look at this, let's see, now I've got this angle is 55 degrees. Oops, 55, and this angle right here it would, these two angles next to each other would add a 180. So I'm just going to go part plus the other part and equal to the whole. And we had 55 degrees, which was one part, plus this part equal to the whole 180. And we only have one variable, so we're totally good to go. Combine these like terms. That gives me 153. Subtract 153. We get 27. All right, solving for z. First, we gotta get rid of the 3, so let's divide by 3. And then I gotta get rid of the square, so we take the square root. And z is equal to 3. Whew. Good problem. All right, rolling on. Number 12. Given the figure to the right, L1 is parallel to L2. Also, the measure of angle A. Angle A is 7x minus 15. 7x minus 15 right there. And measure of angle B is 4x plus 30. There's the statements below are true. Select all that apply. Alright, well these are on a line, so we got to add them together and set them equal to 1. Alright, so we got these two angles, we're going to set them equal to 180 and solve, and then we'll go from there. Alright, so 7x minus 15 plus 4x plus 30 equals 180. Alrighty, we get 11x here plus 15 equal to 180. Subtract 15. Oh, then we get 165 divided by 11. Let's see, what would x equal? 15. Look at that. Awesome. Okay, so how does that really help you? We're going to plug it back in and actually see what these angles are, and then we can tell what's obtuse, we get 90-degree angles, what's what, all that good stuff. So I plug 15 back into this expression here. I'm just going to do right here, 7 times 15 minus 15. Well, 7 times 15 would be 70 plus 35, 105. 105 minus 15 would be 90. So they're telling me angle A is actually 90 degrees. Interesting. Well, did I do my math right? Let's plug that into the other one. What's 4 times 15 plus 30? Alright, 4 times 15, that is 60. And 60 plus 30 is sure enough 90 degrees. So they're both 90 degrees. Clearly, this, you can't take this diagram to scale. So definitely these would be 90 degrees. Now, they said these are parallel lines, so that just means these would be 90. 90, 90, 90, 90. So now let's go through these. Let's see what we got. They say L1 is perpendicular. Upside down T means perpendicular to L3. Yeah, it would be 90 degrees. Yeah, perpendicular. Even though it doesn't look that way, that's what our numbers say. It says D is obtuse angle. No way. All right, it's exactly 90 degrees, so not going to work. C says G and F are complementary angles. Okay, so G is 90 and F is F. Now, that's not, so you gotta be careful. Complementary does mean equal to 90 degrees, but if we added those together, that would actually equal 180. So that's a no-go. D says the measure of angle D plus A is 180. All right, so D is here, which is 90. A is here, which is 90. 90 plus 90 is 180 degrees, so that is true, D. L2, which is right here, is perpendicular to L3 right here. Yep, according to our numbers. Our last one, measure of angle E. E is here 90 degrees, and H is another 90 degrees, is equal to 270. That's crazy. That's equal to 180, so no. Rolling on, number 13. Okay, this is from topic 10. So the figure in the second quadrant, right, so this is 1, this is 2. The figure in the second quadrant of the coordinate plane was transformed into the figure in the first quadrant. So we went from here to here. Select all the statements that apply to this figure. So if you notice, first off, looks like this is just a solid reflection. Notice this point looks like it's at, let's see. Okay, here's 2, 4, 6, 8. I know those numbers are a little bit crooked, it seems like. But these two dots are at -6, and it looks like over here, 2, 4, 6. These dots are at +6. So clearly, this had to be a reflection across the y-axis. You can double check the slope just to make sure. If I looked at this line, it looks like it's a rise up 2, run 4. When I look at this line, it's a rise up 2, to the left, run 4, and that's clearly a nice reflection. All the different lines look like they're the same length, same distance. All right, so we're ready to roll. Measure of angle 2 is equal to the measure of angle F. Okay, so first off, my class is what we did. These are all pizzas. Every pizza should be the same on all 4 intersections, all of them. So if I look, let's just do this real quick, right? 2 is this little tiny pizza slice. It's going to be the same as this one up here. It should be the same as 4, the same as 7. Kind of got cut off, right? If I reflect this over, right, this inner slice would reflect over to this slice, A. And then it would be the same as F. And then it would be the same as C and same as H. So all the ones that I colored are all the same slice, so the same angle. All the ones without a color are just blank. Those are all also the same. So now let's look at this. Measure of angle 2, I highlighted. That was maybe like an acute angle. Is it equal to F? Well, F is also colored in, so absolutely, they'd be equal. Measure of angle 7 plus G is equal to 180. Well, let's check that out, right? 7 is colored, and G is not. Well, think about this. If I reflect 7 over here, it's just the colored angle, and G, they are on a line. Well, guess what? A line is 180 degrees, so that would be true. 5 and A are complementary. Complementary meaning 90 degrees, to add 90. So 5 is up here. A is right here. So I see that they're the exact same angle. We don't know that they're 90 degrees. They don't give us any information to tell us that, so we're not going to select it. Measure of angle 3 plus D. All right, so 3 is here. It's an open angle. Didn't color it in. And D is over here. Is an open angle. Didn't color it in. So we know these two would be congruent. They're saying those two big angles are not equal to angle 1. Look at that. Angle 1 is also an open angle, and so is B. I didn't color all those in. 1 and B would also be the same. Or really, we're looking at the obtuse and obtuse not equal to another obtuse and obtuse, and that's just simply not the case. They would be equal, so we're not going to select that. 8 and D, this is saying they are congruent, they're equal. Absolutely. You got open angle, open angle. I didn't color those in. Those are the exact same angle. And the last one, measure angle E, subtract angle 5. 5's up here, so E minus 5 equals 90 degrees. We don't have any information, again, on how many degrees either one is, so we're not rolling that way. Alright, and the last little bit, we've got 2 proofs. Alright, so with proofs, right, you are the lawyer proving your case to the judge. First statement, generally one of the first 2 is easiest. Notice they give you R is parallel to S. Their first statement is R is parallel to S, so that is simply given. All right, so I'm going to put a little number 1 right there. We use given. Yeah. Measure of angle 4 plus 6 are supplementary. All right, so why, if we just said R and S are parallel, why can we say 4 plus 6 are supplementary? Well, if we are given 2 parallel lines cut by transversal, these same side interior angles are supplementary. That seems like a pretty good reason why we could say that those are supplementary. So if 2 parallel lines are cut by a transversal, same side interior angles are supplementary. Okay, so I'm just going to put a little 2 because we use that for number 2. Okay. Then they say, so measure of angle 4 and then plus the measure of angle 6 is 180 degrees. Well, you can't use the same thing. I mean, that's not, it's not going to be the same thing we just used. If I look at what I have left, definition of supplementary angles, okay, so supplementary means 100 equal to 180. Subtraction property equality, substitution property equality, angles that form a linear pair are supplementary. I mean, that's not a bad option, but really, if we just told a judge that 4 and 6 are supplementary, now we're saying the measure of 4 plus 6, that is equal to 180. That is literally the definition of supplementary. Okay, so then if we look at this, now we're saying, hey, so also you can say 3 and 4 are supplementary. Well, why could I say 3 and 4 are supplementary? Note 3 and 4 on the same line. Notice this last one says angles that form a linear pair are supplementary. Totally. Yeah, totally. So that sounds like a good reason. Angles that form a linear pair are supplementary. And then we have this measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. Well, if you notice, on number 2 we just had said 4 and 6 were supplementary, and then we said the measure of 4 plus 6 is 180, definition of supplementary. We just again stated 3 and 4 were supplementary for a different reason, but we're also stating again measure of angle 3 plus the measure of angle 4 is again equal to 180. It's actually the definition of supplementary again. I'm going to put 3,5. Use that in both. All right, so if you notice how we go from 5 to 6, so now we put measure of angle 3 and 4 added together equal to the measure of angle 4 plus 6. Well, how do we do that? Notice 3 and 4 we got from right here. 4 and 6 we got from up here. What do these both have in common? They're both equal to 180 degrees. So we substituted measure of angle 4 plus measure of angle 6 in for 180 degrees, and that's how we came up with the statement. So we're looking at the substitution property of equality, number 6. Substitution property of equality. All right, so now how do we go from 6 to 7, right? What do we have in common? We still had the 3, and we still had the 6. What was taken off both sides of the equation? Well, the 4 was. Why? Well, we subtracted measure of angle 4 off both sides, and we were left with 3 was equal to 6. So we subtracted, we're using that subtraction property of equality for 7. Subtraction property of equality. Okay. All right, last one, number 22. It says for bisecting an angle, arrange the steps for the construction in proper order. Okay, so we have use a straight edge to draw a line segment CD which bisects angle C, and that sounds like it's at the end. Label the intersection A and B. Haven't done any kind of arcs yet. Using the same radius, draw an arc with the center B that intersects the previous arc and label the intersection D. All right, even if I wasn't a math person, it says using the same radius. That's assuming we did something before that to be able to use the same radius again. So there's got to be a step before that. Draw an arc with center C that intersects both sides of the angle. That sounds more towards the center or the beginning. I'm sorry. Draw an arc with center A across the interior of the angle. All right. Okay. So I'm going to roll with this first one. Draw an arc with center C that intersects both sides of the angle. So what happened here? Right, we have an angle. Okay, we have an angle. Here's an angle. It says draw an arc with center C that intersects both sides of the angle. So the center would probably been maybe right here. Okay, draw an arc. So the arc would have gone like this with a compass. All right, so the second step, if I go back, so draw an arc with center A. Man, you haven't even labeled A yet, so you can't go that yet. Using the same radius, draw an arc with center B that intersects the previous arc, label intersection D. That's going to go a little bit later. Check this out. Label the intersections A and B. Yeah, now that makes sense. We got to have an A and a B before you can start talking about A and B. So I'm going to go with 2 as label the intersection. Intersections A and B. All right, next. Okay, so now we can start talking about like the next arcs that we're going to draw. Notice the last one said, or the top one says, use a straight edge to draw a line segment CD which bisects angle C. So this is C. Eventually we're going to draw a straight line that bisects, that means cuts this in half, and D is going to go on that line. That's going to be at the very end. So I'm going to put a 5 up there because there's 5 steps, and that's going to come at the end. Question is, what's 3 and 4? So down here it says draw an arc with center A across the interior of the angle. So this is when we took our compass, we put the point on A, and we created an arc right here. Right here we made an arc just around A. Draw an arc with center A across the interior of an angle, and there's the interior of the angle, right? Now that's a good 3 right there. And then, so now as we've done that, using the same radius, draw an arc with center B that intersects the previous arc and label intersection D. So you would have taken a compass and you would have drawn, with the same radius, the same width, you would have drawn the same arc right here. Alright, so there was 4. So then that's when 5 says, using a straight edge, draw a line segment CD which bisects the angle C. So basically one of these intersecting points would have been D, so you could put it either way, D, and then you would use a straight edge to draw a line through there, and boom shakalaka, we bisect the angle. Alright, hope you guys enjoyed the review. Good luck, everybody. Study hard. Have a great day.